Hello, and welcome to our third Learn to Code screencast. Just so you're aware, all of this video was produced after the actual session because we had a few teething problems with the recording. All of these sessions are run by the Oxford University Computer Society, and we'd just like to take a moment to mention that next week we have a talk on drones that should be a general purpose talk that's accessible to even a non-technical audience, and we'd love for any of you to join us. You don't need to join as a member, and we'd be more than happy to have you. In this week's session, we're going to be having a look at lists, which are a data structure that are a core part of Python. And for the majority of the session, you'll actually be working individually on a set of exercises that we prepared. You can find all of the exercises by going to this URL and clicking on session 3. But to start off with, we're going to have a brief look at what a list actually is in Python and how we can work with them. So far in this course, we've seen two different types of value: strings, which are pieces of text that we include in quotation marks, or numbers, which we don't have to include in quotation marks. In this week's session, we're going to see lists, which are literally just lists of other Python values. So for example, we can make a list of names of people, or a list of numbers, which correspond to transactions in a bank account. To define a list in Python, we use the square bracket syntax. So for example, this represents a variable that contains the empty list. There are no elements in this list. Alternatively, we can define a non-empty list to begin with. So for example, this defines the list that contains the names of all of the Beatles. There's a few things to note here. Firstly, the spaces between each element of the list, that is John, George, Paul, or Ringo, don't need to be there, but I've written them just for convenience and so that it's easier to read. Secondly, we have to include a comma between each value. It's not sufficient to just write a space, for example. If you've ever seen vectors in MATLAB, or comma-separated values files which are used by some spreadsheet applications, this syntax should be reasonably familiar. Next, we're going to have a look at the length function, which allows us to get the length of a list. When we run this program, the value of number of Beatles will be 4, because there are 4 elements in this list. Although the length of this list is 4, we don't count the elements from 1. So, although John is the first element in the list, we access it by using the index 0. George is the second element in the list, but we access it using the index 1. Paul is the third element in the list, but we access it using the index 2, etc. So for example, if we want to get the first value in the list, we write the following. This notation here, where we include a number in square brackets, is called subscript notation, and it's really important when we're using lists. If, for example, I print the value of first Beatle, we now see that the program will print John, as expected. I can then update the list later on in exactly the same way that I would update a variable. So for example, I can reassign the first element in the list, that's the 0th indexed element, to be John Lennon. Now if I print the whole of the list, you'll see that the contents are John Lennon, George, Paul, and Ringo. This line, however, still prints John because at that point in the program, the contents of the list was John, George, Paul, and Ringo. We've seen that we can mutate an individual element in the list using this subscript notation, but we can also add or remove from the list as the whole. So for example, we might want to append the Beatles' original drummer, Pete Best, onto the list, and that we can do that using a method on lists called append. Then, if we print the list again, we see that the contents is John Lennon, George, Paul, Ringo, and Pete. To restore the list to its original contents, we use the del keyword. So we write del Beatles, and then we have to supply an index. So, because we appended Pete onto a list that was 4 elements long, Pete will then have the index 4, because the index started at 0. So we write 4. Finally, if we print Beatles, we see that the resulting list has Pete removed. Just like strings, lists can be added together. and we call this adding concatenation. For example, say I had a second list. I can then add these two lists together to get one larger list. Finally, we're going to look at how you can use for loops with lists. So far, the syntax that we've seen for for loops required us to use the range keyword. So for example, we might write the following. To iterate through the values from 0 up to 9, because 9 is the greatest integer less than 10. We can do much the same thing with lists. So for example, if I then wanted to print the names individually from this list here, I would have to iterate I from 0 up to the length of names, and I can use the length function as we saw earlier for that. So I then access the ith element, that's the element at index I, using this syntax. Python also permits an alternative way of doing this, by simply writing for name in names, print name. This time round, name will take the first element of names, so that will be John Lennon, because that's what we defined here. Then it will take the second element, so that will be George, then Paul, then Ringo, then Neil, then Liam, then Harry, then Louis. So let's run that and see what happens. And as you can see, we get the same output twice. You can use either syntax in most of the exercises, however some of them will require this first syntax instead. To get started with the exercise, please go to the GitHub URL for the Compsoc sessions and click through to the third session. Each of these exercises contains a function that you need to implement. The first function takes a list of numbers and returns the sum of all the numbers in the list. If you click the Download Test Cases button, it will give you a Python file that contains a piece of test code that will run your function and check it against an expected result. You don't have to worry about how this test function works, but do feel free to have a look at it if you'd like to. To get started with an exercise, save a copy of it locally, and then open it in idle. If I run this exercise, you'll see that it passes the first test because the sum of the empty list is 0, and this function always returns 0. However, you will need to implement a solution that works for any list of numbers that you give it. In the remainder of this video, I will go through the solutions to each of the 17 exercises. However, don't worry if you don't manage to complete all of them. During the session itself, most people only completed 3 or 4 exercises, so don't worry about completing all of them. In next week's session, there'll be an opportunity to continue with these exercises or work on a new set of exercises related to maps. So we had this test rig, and if we run this test rig by pressing F5, you'll see that we do pass this first test for the empty list because the sum of no elements is nothing, but we don't pass these next 2 tests. So we're going to start out by creating a variable called k, which is going to store the sum of the elements so far. And then we're just going to loop through each of the elements in the list and add that to the total k. And finally, we just return k from the function. Now when I run this, we see that I pass all the tests. This third test, where I've got range 10 written here, returns a list of 0 through 9, and that's why the sum is 45. In the second exercise, we're asked to do pretty much exactly the same thing, except that this time we have to return the product. To do that, we instead have to start out with our product value as 1, because the product of the empty list is effectively 1. It's the unit of multiplication. So now we're going to do exactly the same thing as before, where we iterate through each of the elements and multiply our total product by each element, and finally we return k. And as you can see, I now pass all the tests. The third exercise is still fairly similar to the first, except that this time, instead of returning the sum of the elements, we're going to be returning the mean of the elements. So once again, we need to calculate the total of all of the elements in the list. So call k equals 0 as our total, and then just do this. Then this time when we're returning, we have to do k divided by the length of the list. Now this exercise has an interesting problem with it, because if we give the mean function the empty list, it's going to have a divide by 0 error. It's kind of unclear what we should be returning here, because the mean of an empty list shouldn't really be anything. So Python does actually have a value none that we could return instead. And as you can see, we now pass all the tests again. In the fourth exercise, we are given a list of lists and asked to return a flattened copy of that list. Now, interestingly, this is once again almost exactly the same as the sum exercise that we did at the beginning, except that this time, rather than starting out with something like 0 or 1 in the case of product, we actually want to start out with an empty list. So let's call that flattened list flattened, and say that its initial value is the empty list. Then we iterate through each list in the list and append the contents of that list onto the end of the flattened list. And we saw already that we can join two lists together with the plus operator in Python. So all I have to write is this, and finally return the result flattened. And as you can see, we once again pass all the tests. The fifth exercise is a little different to the ones that we've seen so far, because instead we are now given two lists, and we are asked to return a pairwise sum of those lists. So as you can see, that's defined, for example, in this second case, by adding 1 and 3 together to get 4, and adding 2 and 4 together to get 6. Now, in this particular question, we're allowed to assume that the lists are both of the same length. So we start out by creating an empty list, and then we iterate through the indices of the elements of each list. So this isn't the elements themselves, but rather the numbers between 0 and the length of the list. And the reason that we do that is because we simultaneously need to access both lists. And now we run this and see that we pass all the tests. The second part of this exercise is to do exactly the same thing, only we're not allowed to assume that the lists are the same length. If we'd run these test cases with the previous exercises, we would have seen that it would have failed on these last two, because the first list is not the same length as the second list. So we start out exactly as we did in the previous exercise by creating an empty list, except that now we need to compute the minimum length of the two lists, and we're going to store this in a variable L. We can use the minimum function to compute that. Next, we loop over all of the indices between 0 and the length of the shorter list. And we add those pairwise sums to the list z's. Now, if we return z's at this point, we should see that we actually pass the first 3 of the exercises. But we don't pass the second 2, because they have 2 lists of different lengths passed as the argument. To fix this, we then have to consider which of the 2 lists is longer. So, firstly, let's assume that it's x's, which is the first list. We then have to add all of the remaining elements of x's onto the z's list, because we're effectively adding them to 0. And we must do the same for y's as well. only one of these code paths will ever be executed, because if the lists were the same length, then L would have been equal to the length of both lists, and the for loop would have done the addition for all of the list. So let's run this again and see if we pass all the tests. The seventh exercise is a little different to the one that we've seen previously, because in this case we're asked to produce a list based on a number, rather than produce a list based on another list. Once again, we start by creating an empty list that we're going to store our result in. Then, like in the second session, we're going to loop over a range from 0 to n-1. In order to check whether or not a number is divisible by another number in Python, we have to use the modulus operator, which will return the remainder of division. If a number is divisible by a number, the remainder will be 0, so we just have to check for that. Now let's test this. And as you can see, I passed all the tests. In the eighth exercise, we're given a list of numbers and asked to return a copy of that list that only includes the even numbers. Once again, we need to start with an empty list that we're going to use as our result, and we iterate through each element in the list that we're given. We then have to check whether that element, which is a number, is divisible by 2. And we once again use the modulus operator for that. If it is divisible by 2, we add it to the result list. And finally, we return the result. As you can see, we passed all the tests. Now in the ninth exercise, we're asked to do pretty much exactly the same thing, except that this time we're checking a property of strings. So we start out with, again, a result list that we're going to return, and we iterate through each of the strings in the list x's. Now, strings in Python are a little bit like arrays in that we can access each character of the string using subscript notation. So if we want to determine whether the first letter of the string is a lowercase letter, we just have to see whether or not it's in the range of lowercase letters, which goes from lowercase a to lowercase z. And we can do that in a fairly intuitive way. So if x subscript 0 is greater than or equal to a, and x subscript 0 is less than or equal to z, then we add x to this result list. And then we can return the result. In the 10th exercise, we're given a list and a number and asked to rotate the list round by that number. So, for example, the list 1, 2, 3 rotated by 1 ends up being 2, 3, 1. So we once again have to use the modulus operator here, and those of you that have done any modular arithmetic will probably be familiar with the idea here. So we create a result variable. So we start out once again by creating a result variable that's just the empty list. And we then have to iterate through the indices of the elements of x's, and we'll see why in a moment. So we need to determine which element from x's we're going to add at each point. And we do that by this expression. So let's just run that and confirm it works. So let's firstly consider this case with 1, 2, 3. This list is of length 3, and we start out with I equals 0. So we do I plus 1, because n is 1 in this case, and modulus 3. So that's 1 modulo 3. And the result of that is 1. So it gets the 1th element, so that's 2, from the original list, x's, and adds it at the beginning of res. And it will keep doing that until it gets to the end of the list. Then, when it gets to 3, that has the index 2. So when we do 2 plus 1, so 3, mod 3, the result is 0. So then wraps around back to the beginning again and gets the 0th element, which in this case is 1. And as we can see here, that's the expected result, 2, 3, 1. The 11th exercise is the first to make use of the idea of sorted lists, so keeping the data in sorted ascending order. And we start out by being given a list that could be in any order, so we need to sort it. And to do that, we just put it in a new variable and called the sorted function. Then we need to remove all of the duplicate elements from this. So let's consider what the value of y's will be for some of these lists. So for this list 0001, the sorted version of that list will also be 001. However, in the case of this list, it's going to be 114455 because there's 2 of each element and they're all getting sorted in order. So we're going to again create a result variable and iterate through each index of y's. So we do that by using a range again. So we have to determine whether or not we should add an element from y's into res, and we should only do that if it isn't the most recently added element anyway, because res will be constructed in sorted order. So we can make that check using this. Now there's a subtle bug in this program, because initially res will be 0 length, but we're trying to check what the last element of res is here, and clearly that won't work. So in the case that len res is 0, then we should always append the most recent element of y. So we save this and run it. And as you can see, we pass all the tests. In the 12th exercise, we're asked to do binary search over a list, whereas previously we'd only done binary search over a set of numbers. So the test cases in this program are firstly the empty list, then this sorted phrase learned code, and finally a sentence that I found where each word is in alphabetical order. So I'm not going to worry about explaining the code behind this algorithm because we covered it in last week's session. I'm not going to explain all of the code in this solution because there is an explanation in last week's video. So we start out with lower 0 and high this time has to be the length of x's. Then we do our check as before and make a guess. And we compare. So the guess in this case is actually an index of an element in x's rather than an actual element of x's. So we have to compare x, which is the element that we're looking for, with an element that's in x's at the index guess. And if this is true, we then want to reduce high to guess. Otherwise, we increase low to guess. And finally, return low. So the final part of this test will run this against each of the words in this sentence here. And as you can see, we passed all the tests. Sorting is really useful in computer science, and in most programming languages there's usually a function available, like sorted, to sort a list for us. However, it's often useful to have the experience of implementing such a sort function yourself, and in this course we're going to have a brief look at the merge sort algorithm. So, before we start out looking at the merge sort algorithm itself, we're going to write a function merge for exercise 13, which takes 2 sorted lists and merges them together. So, just to be clear what's happening here, if you give it the lists 0, 1, 2 and 0, 1, 2, it will then return 0 and 0 because they're the minimum of these 2 lists, followed by 1 and 1, followed by 2 and 2. Or, in a more complex case, if you have 0, 1, 2 and 3, 4, 5, the resulting list will be 0, 1, 2, 3, 4, 5. The way that this algorithm will work is to have 2 cursor indexes, so we're going to call them I for x's and j for y's, that move through the lists, and when they get to the end of the list, then we know that we only have to look at the other list, but whilst I and j are somewhere in the middle of x's and y's, we have to pairwise compare the 2 elements to decide whether we're going to take element I from x's or element j from y's first. And finally, we also need a result variable that we're going to store this in. So the condition of this while loop is while I is not at the end of x's, and whilst j is not at the end of y's. Those of you that have studied logic will know that you can apply De Morgan's law here and get I does not equal length x's and j does not equal length y's from this expression above. So in this case, we need to take x's, the ith element of x's first, and then increase I so that we're looking at the next element in x's. Otherwise, we take the jth element of y's and append that onto the end of the list. Now we're not actually done at this point, because I could be at the end of x's, but that doesn't necessarily mean that j is, and vice versa. So we have 2 more loops to just handle those cases. And finally, at this point, we're done. Now it's worth noting that only one of these 2 loops at the end will actually get executed, because if this condition wasn't true, it doesn't necessarily mean that both of the loops are both of the lists have been fully processed. It just means that at least one of them has. And we see that we pass all the tests. Now, I'm going to make a copy of this merge function, because we need to use it to implement the merge sort function, which is part of exercise 14. Now, merge sort is a recursive function. So, in the case that it gets given a list of length 1 or less, then we can just immediately return, because there's no point sorting that. Otherwise, we're going to split the list in 2, separately merge sort those lists, and then merge them together again afterwards. So to split a list into 2 in Python, you can use the subscript notation with a colon. So this will get the first half of the list. And you'll notice that I'm using integer division here. It doesn't make sense to have a 0.5 of a list, for example. And then we sort the first half using the merge sort function. And then we're going to do exactly the same for the second half. So to get the second half of the list, we have to start at the halfway point, so that's the length divided by 2, and go all the way up to the length. And finally we have to sort that. Then when we've got these 2 sorted halves, we just need to merge them together and return the result. So now we should be able to execute these tests. And as you can see, they all pass. The remainder of the exercises in today's session are targeted at people that have seen a little bit of maths, so we're going to be representing polynomials as lists. The way that we're going to do this is to have a list such as 1, 2, 0, 3 down here, and have 1 correspond to the coefficient of x to the 0 because it's the 0th element in the list, 2 correspond to the coefficient of x to the 1 because it's the first element in the list. 0 corresponds to the coefficient of x squared because it's the second element in the list, and so on. And in this first exercise, we're going to just print out a nice form of the polynomial. So you'll see that I've written 2 functions here, print polynomial bad and print polynomial. So let's just run this and compare the output of the 2. So I prefer the output of the second function because you'll see that we're adding this extra 0th coefficient term when we don't necessarily need to. Now there's a few things to note about the way these work. So this bad function that we have at the beginning will always use the print function when it wants to print something, and we have to use this extra argument end equals the empty string so that the print function doesn't end with a new line, which is what it would normally do. But we also have to have an extra print at the end to ensure a new line is printed. If you're going to use a print polynomial function for the remainder of the exercises, I strongly recommend that you use this version instead, which instead constructs strings for each of the terms of the polynomial, and then joins them together with the string add at the very end. So in exercise 16, we are asked to add 2 polynomials together. So that's 2 lists that represent 2 different polynomials. And interestingly, this is exactly the same as exercise 6 that we saw earlier. So just as a refresher, that's this code here. And all I'm going to do, therefore, is copy that, because there's no point in re-implementing this. So now let's just run this, and you should see that the tests all pass. The 17th exercise is a little bit more interesting, because in this one we're asked to compute the product of two polynomials. If I've got two polynomials whose degree is a and b, the degree of their product will be a plus b. So for example, if I've got two quadratics which are each of degree 2, the degree of the result will be of degree 4, because at most we could have done an x squared term multiplied by an x squared term. If I gave you two polynomials, the degree of the resulting polynomial will be the sum of the degree of the two polynomials. So for example, if I give you two quadratics, which are each of degree 2, the resulting polynomial will be of degree 4. And you might therefore think that the resulting degree that we're going to have will be ln x's plus ln y's. However, these don't actually represent the degrees of x's and y's, because a quadratic has to be represented by three terms: the coefficient of x to the 0, coefficient of x to the 1, and coefficient of x to the 2. So you might therefore think that we have to subtract 1 off of each of these, as so. But this still isn't right either, because our resulting polynomial has to contain an element for the x to the 0 term at the beginning. So instead we only subtract 1 off at the end. Then we need to create a result list, and ideally we'd like this to be filled with zeros to begin with, so that if two terms are never multiplied together, it doesn't matter. So the way that we can do this in Python is create a list that just contains 0, and then multiply it. So for example, if we know that the degree variable has a value 4, this will produce the list 0, 0, 0, 0. Next, we need to loop through both lists, and we can do that by placing one loop inside of another. Now we need to determine which term we're going to update, and if you tabulate this, it kind of makes sense. So the degree of multiplying the x to the I element with the x to the j element of x's and y's respectively will be of degree I plus j, because for example, if we're doing x squared times x cubed, then the result of that is going to be x to the 5, which is just 2 plus 3. So we store it in the I plus jth element of res, and we also have to add this to whatever was stored in there previously. So these are the coefficients y's and j. These are the coefficients that we're multiplying together here. And then we just return the result. And when I run this, you should see it pass all the tests.